Hey y'all, let's take a look at an Edexcel Paper 3 walkthrough. Question 1 I found really tricky. Question 1 confused me with the English. This is talking about an increase in the division of labor. And here, everything is what you would expect, but the other way around. So A is more division of labor should lead to more boredom, but they've told us less boredom, so that's wrong. B, decreased use of specialization. No, you should be specializing more because you've split your production process into more steps. And D is also totally the wrong way around. You should get lower training costs per worker, which leaves C as the only answer. But C is also right because more specialization increases your production output and per labor, and that decreases the cost per unit of smartphones. The next one was a tricky one about specialization and the function of money. They don't really seem linked. However, specialization is, imagine producing just smartphones. Smartphones are great, but smartphones can't really pay for your workers very easily. Maybe they pay their wages for 1 or 2 weeks, but after that they need food, they need water, they need clothing, and ultimately giving them smartphones doesn't really work very well. Even if they try to sell it to their friends, that's going to break down. So the function that I went through was the function of money. Its function specifically of a medium of exchange was really useful to help actually get workers into this company and as a result be able to produce smartphones on a mass scale. So be sure to link it to the question. I think that's something that you can forget about. Total output of the firm is going to increase because it can actually have workers over the long term. External benefits, these are a little bit confusing. External means it's to do with the third parties, and in terms of where you'll have seen them before, these are the kind of the gaps between your MSB curve and your MPB curve. It's the gap between there and there. And this is actually called the MEB, which is that one. And I've got the definition there, and I've also put the equation, which is what I've just said. The measures a government could use to achieve the social optimum of nursery school places. Let's break that down. So to achieve a social optimum, what you want to do is you want to always be producing and consuming where MSC equals MSB. And on my graph, it's got lots of stuff in it now, but if you try and kind of focus, I've highlighted the MSC in green, the MSB in green, and these things coincide at that dot, that R, which corresponds to that quantity. So going with that rule, the social optimum quantity that we want to reach is Q1. But right now, we are not at Q1. We are in a free market equilibrium, and in this free market equilibrium we assume people are self-interested, we assume consumers are self-interested, and we assume firms are self-interested. And what this means, consumers are going to want to consume according to how it benefits them, and they're going to consume on the MPB. So that means you're looking at that line coinciding with that supply curve, which actually means your output right now is QE. So what this question is asking, we want to move from QE, we want to go all the way to Q1. So how do we do it? Out of all the options, I reckon subsidy is the one that's going to work. A subsidy of the height, RS, that's what it means, RS, the height RS, is going to shift the supply curve. Some people call it right, I call it down sometimes. Shifts a supply curve like this. And as a result, your new equilibrium, if you look at where the new supply curve is going to coincide with the selfish consumers, your MPV, so much going on in the graph, that is going to mean that they coincide at point S, which is your new Q new coinciding with the social optimum. So that's going to work really well. And that's because it reduces firms' average costs of production. So they're more able to produce more, and that helps the quantity to increase. To get the welfare gain area, this is not so fun. All you need to do is I'm going to delete a couple of stuff that's on here. Give us some space. So all you want to do is look at the gain in the quantity. Deleting everything I can. Okay, maybe not that one. We're going to gain this much quantity by going from QE to Q1. So just be sure you look at only that point in the graph. I'm going to just draw this out just to like ignore that. Don't look at that. We're only moving from this QE to this Q1. And then to do that, what is the welfare impact? So to guess the welfare impact, all you need to do is compare the marginal social benefit for each of these quantities. So, for example, at this quantity here, if we go up and find the MSB line, which is there, that's the benefits that this quantity brings to society. I'm going to label this a 10. At that same quantity, go up to the social cost curve. That is here. And that tells you how much this unit costs society. This one looks a little bit lower. Maybe this is like a 7 or a 6 even. So you can see by consuming that quantity, society has been better off. It's been better off by a 3. And then you repeat for all the other quantities. So at the next quantity, again, the benefits are there, which is around a, not sure if that's a 9, numbers 9.5 perhaps. And this is the cost corresponding to that quantity. This one looks about an 8 to me. So again, it's been really good to produce this quantity. Society has gained a 1.5 extra welfare that it didn't have before. And then you repeat this process. Do it for all the quantities between QE and Q1. And if you do that, I've skipped a few steps, but if you do that, you'll find that the welfare that has been gained is that yellow area. So all the difference between your MSB and your MSC has been all the welfare gains. Okay, another externality question here. We have rose production in Kenya. And this rose production is affecting a totally different industry. It's affecting the fishing industries. The fishing industry didn't have anything to do with consuming roses or producing roses, but they are harmed by the production of roses. We see here that fish stocks are being damaged, and so the fishing industry isn't going to do very well simply because of this rose industry taking all this water. So that's what I call third parties. They're not involved at all in the buying or the selling of roses, but they're impacted. So we're looking for something that impacts the external outside of the market. And it's obviously a harmful thing in the production of roses. So that's an external cost. To reduce the impacts of water extraction, I've gone with a tax. Just tax anybody consuming water from this particular lake. I have explained how that should shift the supply curve from S1 to S1 plus T. Let's have a go at drawing that here. S1 shifts left or shifts up, depending how you want to see that. And then this is going to reduce the quantity of roses in this market from Q1 to Q2 and raise the price to P2. It's the quantity of roses and the price of roses. I haven't linked it to the question yet. You need to explain how, because of this tax, it's going to help the fishing community. So be sure you say that there are fewer roses extracted, and roses require water, so that's going to mean less water is extracted, and so fewer fish are harmed. So be sure to link it. I feel a lot of the times it can be tricky to link things. Here we are asked a really cool question about diminishing marginal utility. It's a great definition to learn. All you need to say is total utility is increasing by less as an extra unit is consumed. Watch out, they're asking you to refer to the example, the statement above. So here I've taken the opportunity to say how it's talking about an extra plate at this buffet restaurant. But they're not only asking for a definition. If you look at the question, they're asking for an explanation. So it's really important that you apply it and you help the reader understand what that means. So here I've said that there could be lots of food available in this buffet, and the person could have been generally hungry in the beginning, but as they eat the first plate, the second plate of food, the second plate adds less utility because they're more satiated. Your tummy can't have infinite amounts of food, so this consumer is going to get more satiated and see less benefit of eating more. And less benefit precisely means that marginal utility is falling. And here I've drawn a really great graph. As you consume more plates of food in this buffet, the marginal utility literally falls. And if the buffet price were to decrease, it's a movement along. Remember, changes in price cause a movement along from like A to B. So that's called an extension. Here, a PED equation is a classic question. You always have percentage change in quantity demanded on the top. By the way, so if you forget, just put that on the top. It wants you to rearrange the equation, can be tricky this sometimes. They want you to find the quantity demanded. So what I've done to get that, I multiplied both sides by the percentage change in P, which leads the percentage change in price to cancel out. And then I'm just left with the other parts of the equation, this bit which I've put on the right hand side. Then I've inserted the numbers that they've told me. So they've told me that price has fallen by 20%. And they've told me that the PED is minus 0.2. Two minuses, when you multiply them together, even in your calculator, it should turn out as positive 4. So that is the answer. Okay, the revenue, there are different ways of doing this. I'm going to show you the way that I did it. So first of all, I just said that this is an inelastic PED example, and I've applied it to the example. I think the important thing was to explain what happens to the revenue. This is the way that I did it. So I wrote an equation for revenue as price times quantity. And I've actually inserted the price that they gave us in the example, and I multiplied it by the quantity. And this is going to mean that for the revenue afterwards, the same process, P2 is now 20% less. So somewhere along the way, I would 1.32 times 20% less, which is 0.8. And then I got that number. And I know from the question also that the quantity would increase by 4%. So I increased that by 4% to find Q2. And you can see just by comparing these equations, 1.32 times Q1 is higher than 1.1 times Q1. So you can see here that the revenue has decreased. There are other ways of doing this, but this is just one of the ways. That's it. Section A done. Thanks. Bye.